42. So there have been a few cases where the interviewing project manager hasn't reached out to the team right away. There's nothing to panic about with this. I hope they've all reached out. Matt said he was going to address it in lecture today. I don't know what time his 404 lectures are, but he said he was going to address it in lecture today and make sure everybody's reaching out. But since the interviews are during your lab time, you do know when your interview is going to be. But there were some scheduling conflicts and scheduling issues where your PM to interview you couldn't be assigned as early as we had hoped. And some of it was still shaken up. I think today still I don't know if there was a cancellation. I didn't follow the details, but there was some kind of issue. But everything will be sorted out before that time. Matt will make sure that everybody's reaching out to you before your interview time. So you might not have the Zoom link right away, or whatever method they're doing. I hope they're all using Zoom. But you will get something before that interview time, which will be during your recitation time. Time 4442. All right. Is this meme right now? Testing code automatically in multiple platforms. All right. I had to do some surgery on this meme. It was bugging me because the things were out of order. This format demands a very specific order. I had to swap a few. These two were reversed. It was bugging the crap out of me. Or I'm misunderstanding the format. That's always possible. All right, so let's talk about designing. Anybody have any questions or open issues before I get started, before I start going into slide mode? Plus, I want to finish off this iced tea. All right. 442 prereqs. It's technically just 250. We were talking about, it used to have a senior status requirement, and we've been talking about adding that back on. I didn't follow the rest of that conversation because it was, I don't know, to be honest, it was kind of boring to me. So I don't know where that ended, but we might have some other condition. You like had to take some subset of 300 level courses or something. I don't know if we ended up adding that or not. But you shouldn't be taking it right after 250, but that might still be the only listed prereq still. Because I always encourage students to take it as soon as they could, but then so many students proved to me that was a bad idea because they weren't ready for the level of this course. They just weren't ready for that. So now I'm on the side of adding more prereqs, but I didn't follow the details of exactly what happened with that. But yeah, so many students took the class right after 250, and then they just don't do well. And the big problem is, the strange thing that happens with that is, since they don't need it to graduate, like if you take this as a senior, you're like, I need this class to graduate, and it kind of locks you into taking the course. Students who take it as juniors or even sophomores, they go, like halfway through the course, I don't feel like it anymore. And then they resign. And the problem is that really destroys their group because their team was relying on being a team. And when you resign this class, you're just screwing with your teammates. You're screwing them over. And it's really upsetting. So because of that, I'm more of a fan of adding a prereq. But that's not what we came here to talk about. 306 should be a prereq. Yeah, that'd be nice. But then we were forcing, since this is a required class and that's an elective, we can't really do that. I'd like to require 331 as a prereq, but computer engineers don't have to take 331. So we really have a very small pool of courses we can choose from as prereqs. I'd like to at least add 220, but that doesn't really solve the problem. And I don't remember where the problem started getting complex, and I'm like, I got so many other things to think about, and there are enough people already discussing this. I don't need to be a part of it. But hopefully something happened or will happen with that. If not, maybe I will become a part of that. So let's talk about designing your code for testing. So this is the easiest code to test. You have a function with input-output behavior, easiest code to test. We talked about this with coupling. The loosest coupled code was this functional programming where everything is a pure function. Most notably, there are 0 side effects. So you might want to be tempted to say, well, this is like everything. Everything we code is like this. But you may be forgetting about side effects. So if you have a method that's part of a class, you might take some input and return some output and also change one of the fields of that object. And that's where we have side effects, and that's the other thing that we'd have to test. That makes things testing a lot tougher. So this is the easiest code to test if you're in a pure functional programming mindset. You have very loose coupling between all your modules. Hopefully your modules are small enough and cohesive enough to be to make sense and have good organization. And then you can have a really solid code base. There's one problem with that, one little problem, is functional programming can be tough to understand. Granted, this example that Dr. Hertz put on the slide is from Lisp, of course, which is notoriously difficult to read unless you're really used to it, unless you've been studying Lisp for a long time. So I feel like it's kind of a setup. But even with functional programming in other languages that are easier to read, it's still a tough way of thinking about your programs. Those of you who have taken 305 know what I'm talking about. No, it's just a brand new way of thinking. Personally, I'm of the opinion that if we teach functional programming early and often, like if we taught functional programming to the same degree that we teach object-oriented programming, I don't think it'd be that tough. And I think the world of software might be better off for it. But that's just my opinion. Since we're taught a specific form of programming, that's what we're used to. So functional programming looks bad in this example especially. It's hard to read. They use this prefix notation for operators. But anyway, here's a purely input-output behavior function. For the Fibonacci sequence, it takes 3 parameters, N, A, and B, where A is an accumulator that's storing the sum of what we're computing. And then it's a recursive function. It's going to call itself, with N being in this reverse notation. This is N minus 1, B as the accumulator, and then A plus B as B. If N equals 0, return A. So Lisp, horrible to read, but if this were written in another language, it could still be a pure function, easy to test, and not be nearly impossible to read. Like this very simple function, if you haven't been exposed to Lisp notation, or at least prefix notation, can be tough to read. But that would be great. But that's the setup that Dr. Hertz did. Functional languages, they're constantly gaining in popularity as well. These pure functional languages. But I'd argue you can do functional programming in non-pure functional languages like Lisp, and get the benefits of functional programming without using a purely functional language. So if you do need to create an object with state at some point, you can still do that. It's why I've been liking Scala since I've been teaching it in 116. I'm kind of really starting to like that language. You can use functional when it's appropriate. You can use OOP when you just want your code to be a little easier to write. But that's a topic that a lot of people have strong opinions about. I'll warn you right now. If you ask ask all your professors what they think about functional programming and functional languages, you'll get some interesting responses. I recommend doing that too. It's fun. So in most languages, we're going to use. Ask Luke. He'll give you some good answers. Luke's a functional programming guy, so he'll give you some strong opinions, some good opinions. So most languages will allow us to use some state and side effects with in objects and object-oriented programming and all that, which makes things more difficult to test. So this is usually the reality we're faced with. We're going to use our classes and objects. We're going to use inheritance and polymorphism. We're going to use these things, and in most cases, so that means we have to figure out how to test when there can be side effects. When we have to test a class, we have to create objects of that class, test not just their methods, not just each method, but each method for each state that it can be in. if it has some fields, we have to change the values of those fields and make sure that we still get the behavior that we expect. So the testing complexity gets a lot more difficult. So how do we deal with this? We can't just do input and output. For the Fibonacci sequence, give it n equals 0, n equals -1, n equals 1, n equals 2, n equals 5, and n equals 500. If it does well on all those inputs, we're fine. And since that's written in as tail recursion, hopefully the compiler is flattening that out for us and the 500 doesn't stack overflow, and then we're good. We got it tested. Perfect. With OOP, we have this new dimension of testing. So let's look at an example. Let's talk about this time class, kind of extending the example from last lecture. We have private ints, second, minute, hour. We have some getters which will exist. We're not going to show the code for it, but some getters that we'll talk about. And then one method, advanced time, which takes a number of seconds and then updates the seconds, minutes, and hours. And some getters. There they are. I should have deleted one of those slides so I didn't have to click. I want to stop, right here. So we can, and some getters, so we can access the seconds, minutes, and hours, but no setters. We don't want anybody else being able to change the seconds, minutes, and hours except through this advanced time method. And right here, I want to sit on this slide for, no pun intended, but like a minute. And I want you to think about how you would test this class and specifically test this method, advanced time. What kind of tests would you write? How would you make sure that it has all the functionality that you need? And I'll read up on some chat here. List equals 222, 222. I don't understand. Oh, you're making fun of, no, TypeScript wasn't mentioned yet. I don't know what that example means. Yeah, used well. Functional programming is nice. So I kind of don't like that he used. I get what he was trying to do. He was trying to say, look, testing is super easy and functional, but we're not talking about that. I want to talk about testing object-oriented because that's probably what you're writing in this class. You're probably using object-oriented programming. So let's talk about that. So I get what he's trying to do, but he kind of set it up to get that point across. He used Lisp, which is just a terrible example of a programming language, in my opinion. I know there are Lisp fans out there, but I don't like Lisp, where it's always, if you're... So it takes a long time, and I haven't bothered to do it because I'll just use other languages. But it takes a long time to get used to this notation where to call a method, you start with the method name, and then you give the parameter list, which is kind of, when I say it like that, it kind of makes sense, actually. So you're calling the subtract... Oh, my mouse is on the wrong thing. You're calling the subtract method, or function, sorry. It's all functions in this language. You're calling the subtract function on the arguments n and minus. You're calling the addition function on the arguments a and b. You're calling the fib function on the arguments n minus 1, b, and a plus b. And you're defining this fib as it takes this parameter n, and optionally some a that defaults to 0, b that defaults to 1. So it makes sense if you kind of think about it, but it doesn't make it much easier to read when we're so used to seeing these operators in line. We were used to seeing n minus 1 instead of minus n1. It just hits the eyes in a bad way. I want to see if n equals 0 because that's what every other language does. And Lisp was around before a lot of those languages, so that's not the most fair comparison. But still, Lisp doesn't really speak to humans very well unless those humans have been studying Lisp and seeing prefix notation for a long time. So if you're a fan of Lisp, there's nothing wrong with that. There's just to sum it up, to give the TLDR, Lisp has a very steep learning curve. Once you get past that, I'm sure you can write wonderful programs, but it's a steep learning curve, and anybody who needs to read your code needs to go through that steep learning curve. There are other languages we can use. No chat during that whole thing. Hopefully you all at least thought about how you would test this thing. So you would give it a lot of different values for seconds. Create new instances of this. Call seconds with a lot of different inputs. Call these getters. Get the seconds, minutes, and hours. And make sure they have the right values. And make sure you're hitting all those edge cases. Make sure you overflow seconds. Make sure you give it enough seconds to overflow the hours. Make sure you're hitting hours over 12. Make sure you're given enough seconds to overflow minutes, but not the hour, and overflow minutes and the hour. There are a lot of different test cases you have to throw at this thing. Ideally, I would have getters for the private variables and write a unit test for second, minute, hour, testing the actual versus expected. And so one of the issues and the point of this example is that you have to write different unit tests. You have to make sure the second, minute, and hour are going to be the proper values, but you can only give it the number of seconds, and then you have to check the states, the fields, the values of these fields for each time you call this method. You have to use the getters and get those values. So you have a few different issues that can occur. What happens if this method works great once, but then you call it again and the values in the fields got all jacked up? Since you can't crack open the internals of this class, it's hard to tell when that can happen. Maybe somebody coded this in a strange way, and I don't even, to be honest, Dr. Hertz might have hidden a bug in here. I didn't look at it too closely. But somebody might have coded this in a way that gets the fields jacked up in certain situations. So if you call advanced time of 60 seconds, maybe that works great and all the values are what you expect. And then after that, you call advanced time of 60 seconds and it doesn't work the second time because of the way that the fields were updated the first time. Maybe it doesn't handle that second overflow. So since you can't analyze any of the internals of this class and this method, it's very difficult to tell if those really strange bugs exist. For example, if somebody had separate additional state variables, I said I was going to try to get this straight, but it's so tough because they call them state variables in 116. Additional fields that don't have getters, private fields with no getters that you are completely invisible to you from outside of this class, that are handling these overflows in some strange way, that they're tracking some overflow information. And then as you call this multiple times with multiple overflows, maybe those values get out of sync and they stop working after some time. You would have to test for things like that, and that's where we run into an issue with code like this, is you just don't know how things are actually working between calling advanced time with some seconds and then calling these getters. You can't test anything in the middle, and you don't know what's happening there. So there's a lot of, and with negative numbers, what if you give it a negative number? And hopefully that would just not be allowed. Maybe there should be one, since it's called advanced time, there should be a conditional. Do some checking. Make sure that sex is not negative. But that would be definitely a bug, because this code's going to break if you give it a negative, I believe. Oh, maybe not. Well, the modulo depends what language. This is Java, right? Because modulo with negative numbers does work differently in different languages. I don't know. This code might get away with negative numbers. I don't know. Oh, hours could go negative, though. And minutes could go negative. Yeah, they can. No, minutes can't go negative because we're going to do the mod 60. So if minutes is like -3, mod 60, I'd have to double check with Java, but it might be positive 57. But the hours, underflowing the hours, would fail with a negative number, because we have no check to see if the hour is 0. Yeah, or take the absolute value. But that can be a little tricky, because if somebody's calling it with a negative integer and expecting the time to decrease, then you're going to really throw them off as well. But that would be something you either want to validate the input or have some documentation, just say, hey, don't call this with negative numbers, fool. And then hopefully your teammates obey that. But I don't know. I'd rather have some more security on that. But, that wouldn't fit on a slide. That's not the entire thing of what we're talking about here. But yeah, that should be thought about for sure. Absolutely. So there could be a lot of things that could go wrong here. And we want to be able to find all those bugs, but it's tough to find those bugs when we don't really know what to look for, when there's so many things to look for, I should say, that we have to write a ridiculous amount of testing code and test cases to get that functionality. So we want simpler code. We want to be able to test our code simply and still get all the functionality that we want out of this. So if we separate our code, of course, we're going to change this into, it is -1 in Java? Oh, man. Well, I guess we wouldn't get away with that. So negative numbers completely break that thing, that method. Maybe it's Python that does the wraparound for that. Modulo should be, -1 mod 4 mathematically, I believe, is 3, right? I would want that to be the behavior, at least. Anyway, so we want to separate things as much as we can to make things as easier to test. So things like state change are difficult to test across method calls, but the state change itself is very simple, and the calculation itself is very simple. So if we separate the calculations from the state change, we can have some nice testable code. So if we have our calculations just compute, we can test those as though they were functions instead of methods, and just test their input-output behavior. And then in separate code, we can handle the state changes, which is code that just says, call this method with this input, and whatever it returns, that's my new state. So we test the methods separately, and then the state change either separately or maybe not at all. If it's just a simple assignment, there's not much to really test there. So we don't have to do much with the state changes if all that code is doing is changing the state and updating the state. So in this example, we would rewrite this code to be 3 separate methods. We're going to break up our code into smaller pieces, make more modules, more methods in this case, that are easier to test and do much less, that we can test separately, and then have a method that's going to combine all the pieces that we have. I was just looking over some 116 code for today's lecture before this one, and I have this method to compute dynamic objects in a game that we're making. 2 players can collide with each other. I didn't show them the code because it's the answer to one of their homework things, but I was looking at my code. I was just looking at it preparing the lecture, and there's a lot of vector math. So 2 players can collide, and then their momentum should be preserved, and they should bounce off each other in according to actual physics, according to a 2D collision. What happens with their momentum? Their mass is taken into consideration, and their new velocities are in momentum are identical to their previous momentum, the sum of their momentums and everything. So there's quite a bit going on with that. I can't write that. I can write that as one method, but I shouldn't write that as one method because it'd be nearly impossible to test. So I have my test cases for that, and I don't want to just jam in one method with all of these momentum calculations and everything. So what I did was break that down into multiple methods. There's a lot of vector computation. So I have a method for like dot product. I have a method for computing momentum, etc. I had like 4 of them. I forget what they all are. And then my actual collision method to handle the collisions between, the 2D elastic collision problem. Yes, beefy Indian kid. Exactly. And so my actual collision and my momentum preservation method, my big method that did all this stuff, really just read like a whole bunch of method calls. It spoke to self-commenting code as well. It was each method had a nice name, and it says, okay, you have these 2 vectors, compute their dot product, just call dot product. And it just read kind of like almost like a textbook, like here's what you do, then you do this, then you do this. And it made that method a lot easier to comprehend because I'm not caught up on all the details of computing dot product. That's not cluttering up my code. And I can watch my logic. Okay, I got the right logic here according to the collision problem, the collision physics that I want. And then I can test each one of my smaller methods independently and make it a lot easier to find a bug. If I'm just testing that method directly, I don't know where I went wrong. I don't know what happened to be able to tell where I have an error. But if I'm testing each of these small methods separately, make sure they're rock solid, find the bugs and eradicate the bugs in them, and then I look at my large method that's combining all those method results. I can debug that I can write test cases for that as well, of course. But when I'm debugging those test cases, I'm looking at my logic. Okay, I called this method, then I called this method, then I called this method, and I combined the results in this way. Oh, wait, that's not what I was supposed to do. That's probably why my test was failing. And I can do that relying on all of the smaller pieces already being tested because I already have my unit tests for those. So for this example, we want to take this code and break it into smaller pieces. One, we're going to separate the state updates with the computation, like we said 2 slides ago. And we're also going to break this into separate pieces because this method is clearly doing 3 separate things: updating the seconds and checking second overflows, updating the minutes and checking minute overflows, updating the hours and checking hour overflows. So let's just break it up exactly like that. So we're going to have a method that advances the seconds, takes the seconds, checks the seconds overflow, computes the new seconds, computes the second overflow, and if it does overflow, we're going to advance the minutes. Actually, we're going to advance the minutes no matter what, even if, and assuming this is integer division, of course, because we just have the slash in 2 ints. Java's going to do integer division here. So if seconds is below 60, this will be 0. We're going to advance the minutes by 0, which is a test case we should have. So we should make sure that that works properly. And then the seconds is going to return the computed value. We're not updating the state variable. We are updating the state variable, but we're also returning the new state. So now this is easier to test because we can just say advance seconds of whatever value we want to test, and then check the return value without checking the state itself. So we still might have something that went wrong with the state. We might have those extra private variables like I mentioned earlier, but that's not going to affect the testing of this method. That's something we would test separately in terms of testing the updating of the state variable, that side effect itself. So we can test the side effect separately, and with the hopefully we did that properly and it's working. But state is always a bad thing. State can always go wrong. That's why functional programming is gaining popularity, in my opinion. But we're returning the seconds. So we treat this more as a method. Create a new time class with certain minutes, hours, and seconds. Call this method and make sure it returns the value that we expect. Same with minutes. Call this with the value that we expect without relying on potential cascading failure here. We don't want to call advanced seconds to test advanced minutes. Maybe we have another test for that. But we want to call advanced minutes and advanced hours separately as well to make sure these methods do what they're supposed to do. And then the integration, we can do the full integration test to make sure they all work well together. But if those integration tests fail, we at least have all these other test cases to make us confident in which pieces do pass. If all 3 of these methods are tested independently and all those tests pass, and my integration, my full time and advanced second tests that we have from the previous time we had this example, if that fails, we really narrow down our search of where the bug can be. It's only in the integration, the way these methods call each other, or the way that the fields are updated in these methods. What about writing test cases for a linear stability analysis problem? Not familiar with linear stability analysis problems. Like, what if we have a different equation that behaves differently depending on initial conditions, fixed point eigen... is it fair to compute an exhaustive list of hypothetical outcomes depending on ICs? So we don't want to be we don't want an exhaustive list if one doesn't exist, especially linear stability. But you would want to test various different initial conditions. I'm not going to have a satisfying answer for you here, but you would want to test it with enough different initial conditions to be confident that your code is right. That's not something that you're ever going to test comprehensively, but you would want to test with enough different inputs that you feel good about it. which is pretty much the only thing we can do with unit testing. We can't be exhaustive. But you do have a two-dimensional problem, depending on the initial values. Yeah. You have, the different initial conditions and the different setups for it. Two different things changing that you can change independently. You got a lot of testing to do in those cases. But if you can break it up, like computing eigenvalues, you can break that up into several smaller methods and hopefully do better testing on those smaller things to make that a little easier for you. Look, I tied it into the slide. Yay. All right. Plan, always. Define your modules, define your methods, define your classes. Be careful when you're, especially to design for testing. You want to make your testing as easy as possible. The more planning you do, the less work you're going to have to do later. Write your code to be testable. So let's talk about a few concrete ways to do that. We saw one, break up your methods into smaller methods. Hopefully you've heard that before, and hopefully you kind of understand what that is. And hopefully, if you haven't yet, today you can take that to heart and really start doing that in your methods. It's very easy to write methods that are hundreds of lines long. It's a little harder to start planning ahead of time and thinking about how you can break up a method into multiple parts. I actually just ran into a problem this morning. I was updating that code I was talking about for 116, and I had a method that really should have been broken into at least two different methods, and I needed half of that method. I needed one of its parts, but I couldn't, I got to refactor my code to break it into multiple parts so I can reuse that code. I just didn't have good encapsulation and good, I didn't follow the single SRP, single responsibility principle. I didn't follow SRP on that one, which I should have, and split it up. So it's easy to fall into these traps. This is tough stuff. And in general with these lectures, we're getting into tougher design level questions that we're kind of getting to that next level of software engineering where, okay, you can write code, but how do you write good code? How do you design really well? It's hard, and it takes, I've mentioned this before, but it can take actually I didn't word it like this last time though. But it can take a lifetime to get even pretty decent at this kind of stuff. This is very hard stuff. Even when you get to your first job, your senior devs aren't really going to necessarily be great at this. Hopefully they are. Hopefully they're pretty good. And Dr. Hertz and myself, we're certainly no experts either. We do what we can. We have the experience that we have. But this is really tough stuff. And I'll hit on that. I couldn't resist. I had to say it early, but I'll hit on that in a later slide as well. How tough this stuff is, and I'll show you an example of where it gets really tricky. So a few more tips though before we get to there. I/O is very hard to test. How do you test a method? If you have a method that returns void or unit or whatever it is in your language, it doesn't return any value, but prints to the screen. How are you going to test that? How are you going to test that thing? It's possible. I do it in 115. Those first methods, those first functions that you write in 115 that says write a method or function that prints some word to the screen. And you can capture the output to standard out, and you can test that output. And we do that. It works. But it's a pain. It's tough. Not tough, but it's just more work than it would be if we weren't testing like that. So it's better to separate the I/O from your actual calculations, just like updating the fields from your calculations, which could have been separated a bit more in this example. I would have liked to see this return and then some other method that just calls advanced seconds and then sets second equal to the return value. I'd like to see that more separated. But for I/O as well, we want to separate these, have something do all the math and all the calculation, and return a value. That's the part that you're going to test. And then another method that just calls that method and then maybe prints that value to the screen or sends it to the GUI or sends it over a network or sends it to the database, whatever I/O you need to do. do that in a separate method and then just defer to the other method that actually does the calculations, because then you can test the calculations method without having to worry about the actual I/O part. So that's a bit easier to do than testing the I/O directly. You got to spin up a dummy database server just to test your method. You don't want to be doing that. That's just way more work than it needs to be. I already mentioned all that. But yeah, write your functions. If you have, if you're sending bytes over a network connection, write your functions. Just return those bytes, test those bytes, and make sure that's what's happening in your unit test. And then in your code, the whole program is just going to call that method, get the bytes, and then send the bytes. Have a method that just calls your method and then sends the bytes over the network. That's why I use SQLite in the test environment. That'll work for sure. You'll be able to get away with that. And for integration testing, that is what you want to do. You want to run some database server that's easier to work with, like SQLite, that you don't have to have a network connection for your database. But to do the unit testing at the unit testing level, you don't even want to mess with the database at all. You just want to make sure that one method does what it's supposed to do, and that it is going to end up sending the right values to SQLite or to MySQL or whatever you're using in your production environment. So let's look at an example, another example. We want to test this code. Who would have thought? This code, which if you're anything like me, I might have to take this up with Dr. Hertz later. The mixing of engine and motor really bugs me. A motor is an electric motor. An engine is not electric, not necessarily gasoline, but gasoline, diesel, whatever, something that's not electric. So the mixing of the two just really rubbed me the wrong way, but it's fine. We'll get through it. But if you're anything like me, if that's bugging you too, we'll get through this together. But an engine as a motor, oh no. Anyway, we have a car and an engine. A car has an engine. When you create a car, it creates an engine. And this is where you're going to see things get a bit tricky here. In terms of the past 3 lectures, we're going to pull some things together. So we want this loose coupling, like we talked about. And, I'll talk about that in a little bit. Let's talk about the issue here right now. So say we have this method drive, which takes some distance, which calls the motor's move method. The motor moves some distance and tells us how much gas was used, and then we return how much gas was used. So we want to test this method. We want to test this. It does grind my gears. So we want to test this method that relies on this motor that we don't have access to. So how could this drive method fail in a way that we can't really test for? Grinds my gears. I do have another slide here, right? No, I guess I want to talk about it right here. So this drive method relies on the motor, which is something that we don't have access to. So when we're testing the car class, we actually have to depend on this magical motor engine. We have to depend on this engine class, but we don't have any access to it. So when we're testing car, we're completely dependent on engine working properly. So if there's a bug in engine, our car tests are going to fail, and it's not the fault of the car, but there's no possible way for us, well, I shouldn't say no possible way. There's no practical way for us to test that in a way that allows us to test the car separately from the engine. I say, if I don't say it now, this one's going to bug me too. We can use reflection and remove the private and then actually access the motor and replace it and test it separately. But we don't want to get into that kind of stuff. We don't want our testing code to be that messy. We want things to be as simple as possible and no simpler. So how do we test this? How do we test this car if the engine class is broken? That's going to cause issues here. If this move method in the motor class, in the engine class, is broken or buggy, or even if it's working fine, we just can't test the car separate from the engine. That's our problem here. So what our solution for this is going to be dependency inversion, kind of one of the newer-ish buzzwords in software engineering, is we don't want to hard code everything. We don't want to have that engine strictly inside the car. We want to give it the engine as we create it and have the car depend on that engine at runtime by giving it as a parameter. So when we create a new car, instead of just always hard coding this to always have an engine and have a car depend on the engine class like this, we're going to inject dependency injection. I think that's the same thing. That's the term I'm more familiar with. We're going to inject that dependency at runtime and give it as a constructor parameter when we create a new car. So we're going to give a car a new engine as it's created. Now we have control over the engine when we're using the car class, and this is going to make it easier to test the car. And here's where I want to let me check this comment. I have beef with it too, and that's what I want to talk about in this slide. Creates more problems than less because it breaks encapsulation. Exactly. You know what? I can just read your comment. This is what I wanted to say, or encourages doing so. So it does break encapsulation, and that's my beef with it too. And that's where I want to emphasize. So this is what I was saying earlier, is this stuff is really hard to do. So when I'm talking about like just coupling, you might be thinking, okay, coupling, that's a good thing. We can do that. We're going to add coupling. We're going to add a sprinkling of coupling into our project. Cool. When I'm talking about cohesion, you're probably like, hey, this is good stuff. Like we're going to design this, and we're going to design it with cohesion in mind. Cool. And now we're talking about designing for testing, and you might be thinking, okay, testing, this is great too. We're going to design in a way that makes our code easy to test. Let's just sprinkle that in our project. We're going to shake it all together, and we're going to have this beautiful code base. But this is one of those cases where these three things are kind of at odds with each other. So now we have a bit tighter coupling. You could argue it's looser coupling, and that, again, is another layer of where it gets tougher here. But it definitely breaks encapsulation. So when we use a car, we can't just say, give me a car, and I don't care about your inner details. Now with dependency inversion, we're saying every time you use a car, you have to know about the inner details. You have to know that it takes an engine. You better read up on the engine class. If there are subclasses, you better read up on the other types of engines that you can have, whether this is actually an electric motor or a diesel engine, or an outboard engine for a boat. Like, you better give this car the right type of engine, and it better fit in the car. There's a lot of things you need to know about the inner working details of the car class to be able to use dependency inversion effectively and not run into all kinds of other trouble other places in your code base. So you're completely breaking encapsulation here. So these three things, cohesion, coupling, and testing for writing code for testing, they can be at odds with each other, and that's what makes this such a difficult thing. And most of the time, there are no real answers. You can have debates with other developers, and we can discuss the pros and cons. But it really is important to understand all these ideas and concepts, and then when you're faced with a specific problem, decide what you need for the solution for that specific problem. So if it's a problem where maybe you're just not too concerned with coupling, I mean, you should always be concerned with all three. But if you have to go to like the second best level of coupling to be able to get the best level of testing, maybe you make that trade-off. But it's important to understand for your situation what you're going to do. Do you want dependency inversion? Well, it depends. What's more important to you for that specific problem? Encapsulation and information hiding, or testability? And this, what we're going to see with dummy classes, I forget what the slide's called, but dummy classes, stubbed out code, and things like that. It's a lot of these things are trade-offs. That's why there's no one answer. If this stuff were easy, it'd be a lot easier to be a great software developer. If it were just a matter of maxing out, like you have all these levers, okay, let's max out cohesion, and let's minimize coupling, have perfectly loose coupling and perfect cohesion and perfect testing. If you could just max out everything to the best levels, with no side effects, and your code is still easy to read and easier to onboard new members, then the job would be a lot easier. It wouldn't pay as much, and possibly somebody would even write an AI to do it for you. So there's a certain point where you should be happy that it's difficult, or else you wouldn't really have jobs, or at least as good at jobs and benefits and salary. But this is a very tough thing that takes a long time to even get pretty good at. So, and this is one of those examples where we're breaking encapsulation to get better testability, and you're always going to find things like that. So it's a tough thing. There's nothing easy about any of this stuff. If you want to take it to the next level, guess what Dr. Hertz and I have to do? Grade you on this stuff? Yeah, right. That's why the grading structure doesn't have anything like how good did they use dependency inversion, because it's for one so subjective, and two extremely difficult. But let me catch up on Luxerdis's comments. You got some good stuff going on here. Mock functions, entire modules with very little a single call. And we are going to talk about mocking quickly in 3 minutes. Oh crap! Let me read your comments after. But looks like you got some really good stuff in the chat. So anyway, I really wanted to get that point out there, so I'm fine spending a lot of time on that slide because I want to make sure that point comes across. Because these lectures can sound like just do better testable code and do this and do that. But it's really hard to do all of them at the same time. It's sometimes I'll say all the time, extremely difficult to get all of these concepts in one code base. And sometimes possibly even impossible. So this is where we're going to use stubs and mocks. When we have dependency inversion, let's talk about the benefits and why this actually makes our code more testable. Because I haven't explained even why you would want to do this. I just said one of the negatives of it. So when you have dependency inversion, it does make your code easier to test because you don't have to use the production code when you are testing. You can instead inject some testing code. So let's look at this power plant with a reactor. The power plant has a reactor, and we can't access the reactor directly. Just like our car, we couldn't access the engine directly, and we couldn't test the engine. And when we're testing the nuclear power plant class, since we have that dependency, we can't really test the power plant class if there's something weird going on with the reactor. Maybe both of these classes have bugs that neutralize each other, and our tests pass with broken code. We don't want that stuff. So if we have this check for breach, calls reactor within limits. If it's not within limits, we're going to call its alarm sounding method, and then and return that value. If this is false, so if within limits is true, we're going to return false. There was no breach. But alarm sounding should return true, so we can say, hey, the alarm sounding. So with this code, we can get into some bad situations with this. But if we inject the dependency, if we pass a nuclear reactor as a dependency in the constructor, then we can test this better. Now, when we test, we're going to create a this doesn't have it yet. We're going to create a class. We're going to create a class that's stubbed out. This is a stub class with no real functionality. It's only here designed for testing, and it's going to have very simple, basic functionality. So we want to test the nuclear reactor, the nuclear power plant, without having to depend on the nuclear reactor code, our production nuclear reactor code. So we're going to stub it out with this method that just returns fixed values, hard-coded values, and then be able to test our nuclear power plant class, and it's this check for breach method specifically, without having to worry about reactor messing up with our test. So now we know exactly what within limits and alarm sounding is going to return, and we can write a test for this. We create an instance of our meltdown stub. We give that to a new power plant. We call check for breach, and we know what it's supposed to return. We don't have to worry about any internal state or anything like that. We know exactly what this is going to return because we hard-coded false and true. And then we can create 4 different meltdown stubs, 4 different classes with all the combinations, with the whole truth table for these two return values, and make sure our power plant is working properly depending on the reactor, making sure that that alarm is going to sound at the appropriate times. And then we can test our nuclear reactor production code separate from the power plant, and make sure that does everything that it's supposed to do. And then we should also have some integration testing. Once we do integrate the two, we should have those tests that we had from the first slide. But we can test them separately. So going back to dependency injection and all this and violating encapsulation, my quick and dirty solution, which wouldn't work in all situations, but my general approach, what I would want to do here is have nuclear power plant in the car class, have it enable dependency injection. You should be able to inject dependencies, but there should also be a default behavior. The default should be the production environment, the production code, the nuclear reactor in this case, and then have an option to be able to inject the dependency to overwrite that, either by overloading the constructor, depending on your language, either overload the constructor like this Java code, or have a default value for that parameter if it's missing. So that would be my solution to try to get everything, the best of all worlds, but might not always be possible depending on the exact situation. The other thing is having mock classes where the class isn't completely stubbed out like we saw there, where it just returns values, but it remembers what values were called. So if we have this emergency reporting system, we have dependency injection, and part of the emergency system is to send the alert. We don't want to use our production code here because that's how Hawaii happens. When we're using the production alert system, when we're testing the overall system, we don't want to use that during testing. So here we're going to put a mock class, build a mock class, which stubs out the send alert method, but not completely stubbed out, doesn't do nothing, but it's going to update a Boolean just to mark that it has been called. So we can know that that method was called without actually sending this alert to people and creating mass hysteria. Now in our testing, we're going to inject that mock alert. We're going to call incoming missile, and we're going to make sure that this method was called. We have no return value here to test. We're just going to make sure this was called by checking that variable to make sure that that was set to true. Then we know that that system did get the signal to sound the alert, and then we could test that code separately, not on the real thing, make sure that it doesn't go out to people. But we know that the signal got sent, that the emergency system did send the alert system the message, hey, go fire this off to everybody, without actually firing it off to everybody.